Welcome back to another Geography 215 math video. This is the math video for Chapter 1. Before watching this video, make sure to have your math notes and the math questions for the chapter ready. The learning objectives for this video are to learn about averages, isobars and intervals, solid and liquid equivalencies, and temperatures in the atmosphere. Let's first take a look at averages. You can compute averages for weekly, monthly, yearly data, and more. The problem asks to find the average temperature for the month of July in Muskegon, Michigan for 2017. Here are the average daily temperatures for Muskegon, Michigan in July 2017. What you are going to want to do first is set up your average equation. To find the average, what you are going to have to do is sum the variables and divide the sum by the total number of variables. So in this case, the numerator, or the top part of the fraction, is going to have the sum of the daily July 2017 temperatures, and the denominator, or the bottom part of the fraction, is going to have the total number of days in July 2017. Putting the variables into the equation, the numerator has each day's average temperature. The denominator will have the number of days in July, which is 31. Once you add all of the daily temperatures together, you will get 2,218.5, and you will divide that by 31 for the days in July. This will give you an answer of 71.56 degrees Fahrenheit. Therefore, you can say that the average monthly temperature for July 2017 in Muskegon was 71.56 degrees Fahrenheit. Now let's learn about isobars and intervals. Isobars are lines on a weather map that are joining locations with the same air pressure, or every point on the line has the same pressure. Isobars are intervals of 4 millibars on a surface weather map. The figure on the left is a low pressure system. The L represents the lowest pressure around, and as you go out of the low pressure system, the air pressure gets higher. So for example, the first isobar around the L is 980. But as you go out, it increases. So you got 984 and 988 because you're going away from the lowest pressure. The figure on the right is the high pressure system. The H represents the highest pressure around. So as you move away from the high, the pressure decreases. For example, suppose that there is a low pressure system with the innermost isobar labeled at 972 millibars. What would the next outer isobar be labeled as? You can see an example in the figure. Remember that the isobar lines go in intervals of 4 millibars, so you would add 4 to the 972 millibars because as you move away from a low pressure system, the pressure increases. So 972 millibars plus 4 millibars is 976 millibars. Therefore, the answer to this question will be 976 millibars. Let's move on to the mean daily temperature. For this example, the high temperature is 95 degrees Fahrenheit and the low temperature is 57 degrees Fahrenheit. What would the mean temperature be? Remember the average or mean equation? The average is the sum of the variables over the total number of variables. Filling in the variables into the average equation, the top part of the equation has the variables, which in this case are the high temperature of 95 degrees Fahrenheit and the low temperature of 57 degrees Fahrenheit. With the bottom part having the total number of variables, in this problem there are two variables, the high and low temperature. If you add the two temperatures together, the total is 152 degrees Fahrenheit. When you divide 152 degrees Fahrenheit by 2, you get an answer of 76 degrees Fahrenheit. Therefore, the mean, or average daily temperature would be 76 degrees Fahrenheit. The water equivalent is important when measuring precipitation. When it snows, there needs to be a way to measure the snow in a rain gauge. Therefore, they take the water equivalent. On average, 10 inches of freshly fallen snow melt down to 1 inch of liquid water. This is a ratio of 10 to 1, or 10 over 1. Let's try this question. The water equivalent depth of 22 centimeters of fresh snow is about what amount of centimeters? To solve this problem, first set up the ratio equation. To make a ratio equation, the given snowfall and water equivalent goes on the left, which has the snow total on the top, and the unknown water equivalent, or the value you are trying to find, on the bottom. On the right side of the equation, you are going to have the average ratio for snow to water equivalent, which is 10 to 1. Now solve the equation by cross multiplication. First, fill in the ratio equation by putting the snow total given on the top left, and in the bottom left, leave it as x because the total is unknown. On the right, put the ratio of snow to water, which is 10 over 1. Next, cross multiply. So the 22 centimeters is times by 1, and the 10 is times by the x, or the unknown. Now you are going to want to get x by itself, so you will be able to solve it. To do this, you are going to divide both sides by 10 to get x by itself. On the right side, the 10's cancel. With the 10's canceling on the right, only x is left over on the right side. And on the left side is 22 centimeters divided by 10. Now solve for x by dividing 22 centimeters by 10. This will give you an answer of 2.2 centimeters. This slide shows all the work we just did in one slide. The water equivalent depth of 22 centimeters of fresh snow is about 2.2 centimeters. Now let's move on to temperature in the atmosphere. Temperature in the atmosphere is important in meteorology because many of the processes happen in the atmosphere. In the portion of the atmosphere where most clouds occur, the air temperature decreases with increasing altitude. This figure illustrates that as air goes up from the ground, it cools. Keep in mind that this is just an example, and the numbers are just to show that the temperature cools when the air rises. This ends the Chapter 1 math video. If you have any questions, please let me know.